Hey guys, today I'm going to go over the multiple ways you can wire up your bump function for Holley EFI. This is the first. Since we're homeschooling and all the kids are out of school for coronavirus, I decided to get an extendable magnet and use it like my teachers used to beat on things to get our attention. So, today's lesson. This is one way of wiring up your bump function, okay? So, my girlfriend's gonna pan out here. She's gonna show you the rest of what I got on my table. ECU. Bump button. I just grabbed two different buttons that I probably wouldn't use for bump or transbrake, but they're blatantly different, so it's easy for you guys to distinguish. Transbrake button. This is simulating a ground, okay? This is simulating power, okay? So this doesn't necessarily have to be the battery post. I don't suggest it to be the battery post, but this could be a power distribution. This could be a fused output from a relay board. This could be whatever you want it to be, okay? Something good though that's gonna carry the amperage, okay? Got our solid state relay. This one's important. Need this one. If you've got something off of eBay for 12 cents or Wish and you bought 38 of them for $1.27 and they came from Wuhan, China, I'm not helping you. I don't care if you have that. Okay, talk to somebody else. We're using this. We're using this, or you're going to turn this video off and you're going to buy a Davis Technologies bump box and you're going to follow his diagram. Okay? So don't ask me about your Wuhan, China relay that your cousin's brother's uncle, who's YouTube ASE certified mechanic, told you to use. Don't care. Not using it. I'm not soldering diodes and all this other crap and capacitors together. This isn't a science fair project. We're using that right there. Okay? If you need to know what that is, I'll put a link in the bottom here. But there you go. There you go. Right there. It's part number. See it? Right there. Put that into the interwebs, okay? And it computates, and it pumps out that, and then you buy it, okay? Buy from a dealer too, because dealers are cooler than Summit and Jags, and they know more about this stuff. So that right there. All right. And no, don't contact me. I'm not selling them to you, because I don't care. I don't have stuff for sale. I'm doing this to help you, not me. All right? So, what else do we have here? We have a steering wheel. Okay? It's got buttons in it already. See? Okay? See? Buttons. And then this is a torque converter, because I don't have a Transbrake solenoid, so this is going to be our Transbrake solenoid. Okay? It's just a really big one. It's blue, it's shiny. Plus it's pretty sweet looking because there's a bunch of billet aluminum. It's all machined. It's a bolt together converter. And it's the baddest converter on the planet. And I felt like using this instead of a Transbrake solenoid. So how about that? All right. Now we're gonna go back to the diagram. Battery. Now this is just a representation. Like I said, this is not from the doesn't have to actually hook directly to the battery. Okay, I suggest this being on, this orange wire right here. Orange wire right here. Okay, fuse it. Okay, come off of somewhere that's fused, or don't come off of somewhere that's fused. Whatever. But that needs 12 volt or 16 or whatever. Okay, but that needs 12 volt. So orange goes to 12 volt. Now, I made a video in the past that showed this orange wire getting hooked through the transbrake button, all right, and it would carry the load. The reason I did the first video that I made years ago is because the thought process was, what is the easiest way for somebody to add the bump function to an existing transbrake controlled car that's already sending the transbrake signal to the ECU. That's why I did that, okay? That's why I did that. So if you're starting over from new, right, it's a brand new installation, this is the way we're gonna do things, okay? I probably should not have tried to make it easiest for you guys, because y'all have proved that if anybody is capable of making something that's relatively easy difficult, it is Facebook. Okay? So, we're going to start as if this is a brand new installation. All right? So, back to our diagram. Battery, again, is just a representation of positive and negative, okay? So negative is ground, right? I don't think we need to go over that. And positive is power, okay? Orange wire from solid state relay goes to power. So the first two things we're going to hook up is the orange and the blue. The blue goes to your Transbrake solenoid. That sends power, okay? That sends power. Now, if you've got a Transbrake solenoid that has to be pulsed with the ground, you'll be doing this backwards, basically. Okay, so your positive is going to go to a negative, and then this is going to go to the Transbrake solenoid negative side, and then this right here is going to be a PWM positive output. If you've got one of those Transbrake solenoids, I'm going to make a suggestion that's probably not going to be appreciated, but throw it away and put a real Transbrake in the car. Okay, so we send 12 volt, 16, whatever's going in is coming out. So, orange to power, blue to the Transbrake solenoid, but in this case, my torque converter is being used as a Transbrake solenoid for demonstration. Right here, like this diagram. Okay, bing, bing, there we go, there we go. Those two are done, okay? We're done with those. We're done with those after we mount this, but you know what I'm saying, okay? Now, the third wire on this solenoid, and the reason we're doing this, the way I'm doing this video here like this, is because this has to be hooked up a certain way, and that's it. It's not refutable, okay? You can't argue it, okay? This right here is our activation wire, black with a yellow stripe. This uses a PWM negative, okay? So if we're sending 12 volt here, and it's going through here, then this right here has to be a ground to complete the circuit inside of the solid state relay to send our 12 volt out to the Transbrake solenoid there. So this is a PWM negative, okay? So it's pulse width modulated negative, okay? Which means it's a ground, okay? In the ECU, it's going to say PWM and then a minus sign, all right? So you're going to hook that up to PWM negative in this battle area right here, okay? So that's all done. Can't argue that. None of that is up for debate. We're done. All right? We don't need any more questions about it. The only questions are going to come from the buttons. Okay? So, if you've got a HP ECU, a Dominator ECU, we're going to follow this way of doing things, this first diagram. All right? Now, if you want to use the staging that's built into V5 from Holley, you can wire this the same way. If you want to use the staging that's in V5, you're better suited to wire this way. But we're going to get to that in a minute. We're going to do this one first, okay? So this is how I do this, all right? Now, we've got this all done. All right, so there we go, SSR, that's done, PWM negative, that's done, Transbrake solenoid, that's done. So basically from here on up, that's all done. Now we're left with the buttons, all right? So, we look over here on the workbench, we've got a positive spot, and we've got a negative spot, all right? If we're doing things my way, we don't need that, all right? We only need this. Okay, so we've got two options. If you've got an HP, what your option is going to be is to grab 12 volt somewhere, and again, this is just a representation for 12 volt. So if you want to grab it off of a fused power somewhere, this is very low load. There will be no load carried through the buttons this way, okay? So grab your 12 volt from somewhere that's fused, whatever you want, right? Don't grab it from the same spot that you're powering your ECU. Don't grab it from the same spot that you're powering the dash from. Don't be dumb. Okay. So what we're going to do, we got 12 volt. There you go, red wire, 12 volt, it's going there. All right. What do we got here? Boom, we got 12 volt. There we go. Now we're sending 12 volt from there into the button, into each one of these buttons. Then, hang on, we get some different wire. Here we go. Now what we're doing, I'm gonna put down my pointer here for a second. We'll get back to that. We're sending 12 volt through that little red wire there. No shit. Just coils up on me. We're sending 12 volt through this red wire to the ECU. Okay. From there, and another one to the ECU from there. And that's going to be a 20 volt input, the bump button. Okay. I can't get this and stop coiling up. You get the point. So you've got, just like the diagram shows, positive here, splits off, it goes to the Transbrake button, the bump button, okay? And then here we've got a 12 volt input to the ECU and a 20 volt input to the ECU. Now, if you're using staging, the staging setup through V5, and you're not gonna do the bump setup my way, then this, you could do this in ground. So this can be ground signal in, and then this can be a ground input, ground input. If you're doing it my way, this is the easiest way to do it, okay? Now, something I do if you have a dominator. If you've got a dominator, you've got tons of outputs, right? So I like to power lots of stuff off of the dominator, lots of low current stuff off the dominator. So what I do is I enable an output, a 12 volt output from the ECU. I call it button power. I turn it on over, you know, battery over 8 volts or something like that, right? And it's going to send 12 volt out of my ECU here. And it's going to send 12 volt from here to this button and to that button. And then when you press those buttons, it sends the 12 volt back to the ECU as an input, okay? So it cleans up the wiring a little bit. Now, that's how you wire this up. Hopefully, that explanation gets through to everybody and makes life a little bit easier for how to wire it up. This previously in a video I made, it was called a V4 bump function or something like that. It still works in V5. I prefer this method, and the reason being is because in the software we can build a 20 volt or a PWM negative table, and we can offset how aggressive the bump will be in based off of RPM or boost or whatever we want, okay? So if your car bumps in nice and smooth on 8 pounds of boost and 4,000 RPM, and you do things my way, you can adjust your duty cycle of this right here to make it bump in nice and smooth at 4,500 and 12 pounds of boost or 15 pounds of boost. If we don't do it my way, right, or if you have a Terminator X, you're stuck with doing the staging way because there's no 20 volt inputs on a Terminator X. If you don't do it my way, you're going to have to adjust your staging output every single time you make a change to the starting line tune-up. Where we race, the starting line tune-up gets changed quite a bit, and this is why I prefer doing it my way. All right, we're going to go into the software here in a minute for this, but now I want to show you how to wire it if you're going to do V5 staging or if you're going to do staging through your Terminator X. That brings us to that diagram. It looks similar, and I'm sure these are going to be screenshot off of this video countless times and shared all over the place, and everybody's going to get confused, and it's going to equate to just a whole bunch more messages and posts and whatnot. But please watch the whole damn video. Please watch the whole video. You'll learn something. Don't fast forward. Watch the whole video. All right. My girlfriend's telling me to stop with the little pointer. I'm getting excited. So now, if we got V5 staging or Terminator X, we have to use ground. Okay? So this didn't change. battery positive, and again, this is just simulated. You know, you're gonna have a fused location here, right? So it's not directly to the battery, whatever. And then you've got your blue wire out to your Transbrake solenoid, and then you've got your PWM negative. So none of that changed from the previous instruction. None of this stuff changed up here. This is all the same. The only thing that's gonna change is the buttons, all right? So what we're gonna do is all this red wire is gonna come out, and red is just, the ECU, the buttons, they don't care what color the wire is, I promise. It was just for demonstration. This is gonna be removed, and it's gonna be replaced with this, which is ground, okay? So with this, we're sending ground out of, we're gonna send ground from here to each button, all right? There we go, goes to the buttons, and then it becomes an input. So you've got a ground input and a ground input. Back here to the ECU. So you got ground going into the button, the bump button, ground going into the Transbrake button, and then you've got, I only cut 2 pieces of black, whatever. You understand. Then you'll have ground inputs from the Transbrake button and the bump button to 2 separate locations on the ECU. All right. That's as how as it goes for wiring. So this diagram works for Terminator X or V5 staging. All right. So again, both diagrams are the same for this, but they change if you're going to be V5 staging or, look at that, my girlfriend is Term X. There you go. She's brilliant. Or V5 staging. And then look at that. And then this is Devin's, all right? So she wrote that. This is the right way, but this is my way of doing it. And then that's the Terminator V5 staging way of doing it, right? So obviously Term X, or if you want to use the built-in V5 staging in the Holley software, this is how you would do it, okay? If you're going to do it my way, or many other people's ways, right? So I didn't create this or anything, you know, I don't think I did. I might have. Actually, I think I had something to do with this. But either way, this is the way you would do it for that. All right, so now we're going to look at the software, and I'm going to walk you through how to do it in the software both ways. So hopefully this ends all of the questions about this. And again, if all of this is too intimidating for you, I suggest you stop what you're doing right now and call up Shannon Davis with Davis Technologies and just buy one of his bump boxes. And then install it. And then you're done. Okay, so let's go look at the software. Now we need to set up our bump function, right? Our staging function. So what I'm going to do is we're going to start all the way from the beginning. So we're going to open up Holley Efi V5, and we're going to open a global file. Now you already should have a global file started, but if you don't, I'm just going to pick one at random. There we go. I don't even know what this is for. It doesn't matter. So if you look up here, there's a few things missing, but we're going to add the I/O input. So toolbox, add individual configuration. This is a turbo car, so we're going to add the boost configuration. Dual port wastegate. Okay, we're going to select a 5-bar map. Then we're going to add one more. Toolbox, add individual config, I/O. And we're going to do blank. All right, so we populated 2 new icons up here, right? Boost and I/O. So we need to make some inputs, right? So here we go. We're going to name the first input. We're going to name this one Transbrake. Well, actually, we're going to name it T-brake button. All right, and then this one we're going to name bump. Okay, we have to enable them both. Transbrake button, the first way I showed you, is going to be a 12 volt. It's going to say, hey, you know, this input type has changed. You have to configure the parameters. Okay. Then the bump button is going to be a 20 volt input. Okay. Now, we don't really have to configure anything with these inputs because we just want to be, so it's 20 volt, right? There's nothing to configure here. We don't need warnings or anything like that. And the Transbrake button's 12 volt. There is no way to configure it because there's nothing to configure. Then we have to create an output, and the output is for our solid state relay. So let's go out here. We're going to call this one bump output. Okay? Going to enable it. And remember, I harped in on you about this, PWM negative. It's going to say, hey, we need to configure these parameters. So hit OK. So first thing we're going to do, we're going to come back to this in a second, but we're going to go into the pin map. Okay? So pin map. Now notice we've got inputs. All right? Now, if you have an HP, these are all the inputs that you have. Okay? So we'll just do it as if we had an HP. So we're going to drag and drop this one here and this one here. Now we have to go to view outputs because we created an output for our bump. And here's our bump output, PWM negative. We're going to drag and drop here. Side note, this is where a lot of you guys ask questions and you say, hey, I only have 2 PWM negative outputs on my HP. What am I supposed to do with the boost solenoids? I'm going to show you real quick. I don't want to spend a lot of time on it, but we're going to go done. We're going to go boost ICF. We're going to click inputs and outputs. Right here, the boost minus solenoid. We're going to change that from a PWM negative to a PWM positive, which means it's going to pulse the 12 volt side, not the ground side. All right. So that means that one of your boost solenoids is going to get grounded. The other one is going to get power. Okay. Instead of sending 12 volt to both of them and then pulsing the ground, you're going to send 12 volt to one, ground to the other. You're going to pulse ground on one and pulse positive on the other. If that makes sense. Now, if you come back to the pin map, we go to view outputs. Now we've got room where we can drag and drop where they belong. Simple as that. Okay? So we've got them pin mapped. Now again, bump output B10. That means the wire's got to go to B10. J1 B10. It's the second connector over. It's on the output circuit. B10. All right? Or B3. Inputs, same deal. A3, A12. All right. So now it's done. Now, in order to, you know what's something I kind of missed? I didn't miss, I skipped it. Boost ICF, Transbrake launch input enable. Okay. We want the ECU to see the Transbrake, and we want the ECU to start all of its timers for boost versus time and how much dome pressure to apply while on the Transbrake. So we're going to enable that. We're going to go back to the pin map. Notice it populates Transbrake / launch, but it's a ground input, right? So we did this intentionally. I want you to see, you guys ask, man, I can't drop it on here, right? I can't drop it with the Transbrake button. Well, done. Back into inputs and outputs. T-brake / launch is a 12 volt. Go back to pin map, T-brake / launch, bing, bang, boom. There we go. We drop it on with the Transbrake button. Now, you don't necessarily need to make the input called Transbrake button. You could just use T-brake launch, but I did this for educational purposes so that you guys understand how this works. All right, hit done. Now we need to configure the output. So we click our IO ICF, go to outputs. There it is, our bump output, PWM negative. It's in J1B10. It's enabled. Now we need to configure it. So our bump, now this is going through things my way, the way I do it, okay? So our bump, right, has to have a switched input trigger. So the only way the bump's going to work is if the Transbrake works, okay? So switched input, this output will activate when the T-brake button is enabled, okay? So you don't want the bump function to work when you don't press the Transbrake button. So the only way this is going to work is if you press the Transbrake button. And then you can add more caveats down here too for the Transbrake to not function, over X drive shaft speed, whatever. But either way, the only way the Transbrake is going to function is through the bump output. And the reason why is because the bump output is what's activating our solid state relay. So our solid state relay is not going to output 12 volt to the Transbrake solenoid unless this bump output is working, okay? So, something a lot of people seem to miss, go to linked outputs, make sure it's 0. Timer, skip that, go right to Pwm Setup. Now, this has been beaten to death many a times, but we're going to do it again. Type is going to be fixed. Frequency, this has been a topic of conversation here. What I want you to start with is 15 hertz, okay? Table unit is duty cycle. All right, so duty cycle, the way that works is if the duty cycle is 100%, it's 100%, that means the Transbrake is enabled 100%, means it's working 100% of the time, okay? Now, we need to change our X and our Y axis. So the first one we're going to do is Y axis, and we're going to change it to bump button. So bump button right there. And now this is why we needed a 20 volt input, so we can have a scale, okay? Then the X axis we're going to change to RPM. Now, RPM is typically what a lot of people change for the rev limiter and for how much power they want to leave on. So it's easiest to do it this way. So you're going to pick a range in which you think the car is going to leave in, right? So let's just go 3,500 here, and then 36, 37. I'm just going to fill them all in. I know it sounds monotonous here, but this is what we're going to do. Oh, I screwed up. Look at that. Trying to go too fast and not pay attention. 3,900, 4,000. Whoops, we wanted to start 3,500, right? So 3,500, 3,600, 3,700, 38, 39. I'm going to do them all, even though, you guys get the point. And I'm not even going to entertain the fill row values part of it because it's going to add more questions. So I'm sure some of you guys are watching and going, man, you know how to use fill row values, just do that. Nope, doing it by hand. Okay, so now we're going to anticipate that we're going to leave somewhere between 3,500 RPM and 4,900 RPM. Pretty large window. This is why I like to do things this way. So the reason the first one is 0 is because we're going to test it in the shop. All right. So the first thing we need to do is the way this table works is we're going to key in duty cycle for this entire table. And this entire table is based off of what RPM are we at and how much bump button voltage. So if the bump button is not being pressed, the voltage should be 0. Some of these buttons, the cheaper ones, they'll float a little bit of voltage. So I always suggest to change this value to 10.0, all right? And then change this value to 10.5, okay? Now, a 10.0 and down, it's not seeing any voltage. The bump button is not seeing it, the bump button input is not seeing any voltage. So we're going to key in 100% duty cycle from 10 volts on down. So that means that you're not pressing the bump button, right? So the ECU doesn't see any of that voltage, right? So we're not pressing the bump button. From 10 volts down, we're at 100%. What that means is that the Transbrake is working 100%, all right? Now you need to make an adjustment for what happens when you press the bump button. So if you left this 0 all through here, what that means is it's going to turn the Transbrake off. So if you press the bump button, it's going to shut the Transbrake off. Okay, so the car's just going to leave. Now, if you were to key in, let's just say we highlight this entire area and we key in 50%, that means that while you're holding the Transbrake button, when you press the bump button, half of the time that it's seeing that input, it's going to turn the Transbrake off, and the other half of the amount of time, it's going to turn it on. It's happening a lot faster than I just explained, but that is how it works. So I typically suggest people to start, and this depends on your Transbrake solenoid, it depends on your transmission, your starting line ratio, your converter, the whole 9 yards. There's a lot of variables that play into this, okay? But if you got a 2-speed turbo 400, typically you're somewhere around 86%. If you've got a power glide, you're typically somewhere in the neighborhood of like 83%. And again, it changes dramatically based on your transmission, your converter, your Transbrake solenoid. So these are numbers, these are literally numbers just to start with. So if you want to start, let's just start with an easy number of 85%. Now, this is where it gets, this is where people start to get annoyed. But it shouldn't be annoying. You should be happy that this is the way it works, because now you have some adjustability. If you spool the car up and it makes, say you're at 4,000 RPM and you make however much boost, you press the button, right? And the little yellow dot goes up here. You press the button and the car just leaps forward, right? It's like so violent, right? You have to go up with this number. Okay, so 85 is going to turn into, let's say 87, right? So go up 2. If it's unbelievably violent, go up 4. If the car doesn't move, go down. So hang on one second. I got somebody here at the house. Hang on. Yes, showed up. So, like I was saying, if you're at 4,000 RPM, you spool it up and this thing leaps, right? You want to get closer to 100%. So if it's really violent, go up with the number. So we'll do 89 or something like that. And if you try 89 and the car don't move, then you have to come down. So maybe you bring the whole table down to 88. I like to make wholesale changes up here for the first time. All right. The reason being is you're going to change the whole table above 10 volts to 88% because you want to get a baseline, right? So if you've got a good understanding of where you think you're going to have to leave with power, you want to get that number nailed down so that this car creeps, all right? So set the whole table to 88%, 89%, whatever the number is, 90%, until you get the whole thing to creep, until you get the whole car to just creep into the next bulb. And I'll fire up the camera and I'll show you on my concrete floor here in my shop how I've done it and how I can get this. If you can get it to creep on a smooth, slick concrete floor, you won't even know the car is moving when you're at the racetrack. So you key in that number, you get that number nice and tight. Now, if you leave on less RPM, right? So say, remember, 4,000 was our guesstimate to start off with. If you leave on less RPM, you need to make the Transbrake interrupt a little bit more violent because you're going to leave on less power. So we're going to knock that number down to 89, right? And then we're going to knock this one down to 88. And again, every single one of these RPM increments are going to have to be kind of fine-tuned. But the beauty of this is once you get it where you want it, you don't ever have to touch this again, right? So, and say if you leave at 41, say 4,000 and 4,100 or 90, that's good. But when you start going a little higher, right, you want to go, maybe you want to move this one to 96, and you're going to fill the row values like this. Bam. Now you've got a nice linear table that is going to keep this thing from moving too violently every time you go to bump in. So you don't ever have to go back and mess with it again. So once you get this dialed in, that's all there is to it for the way I set it up. Now, if you wanted to set it up with in Terminator X or with V5 staging, it's a little bit different of a scenario, okay? So let's go back. We're going to go here into the system parameter ICF. We're going to go to basic IO. We're going to go to staging. Okay, we're going to enable it. You have a choice. Do you want a single pulse or do you want duty cycle? Duty cycle is what we were just working with, so let's do that, right? So let's just put that duty cycle to 85. And then time, we're going to put to 0.015. All right? This is where you're going to adjust it. I'm going to be honest with you. I don't mess with this at all. I don't do it this way. So read the instructions. If you don't know how to get to the instructions, you go to help, you go to contents. But read the instructions on this, I'm going to show you how to pin map it, okay? So if you wired it for ground, we enable the staging right here, and then we're going to go down here to input output. We have staging input 1, which is your Transbrake, staging input 2, which is your bump button. All right, so staging 1 is Transbrake, staging 2 is bump button. Go to pin map. There you go. You've got your 2 ground inputs, right? There, and there. And then you go to view outputs. You got your staging output, and it's PWM positive. You can change that inputs, outputs to your staging output. You can change that to a PWM negative. So as far as adjustment on V5 staging and Terminator X staging, you're on your own. That's not how I do it, but that is how you wire it. That's how you program it. As far as tuning it, you're going to go into here, basic IO, staging, and then you'll be changing things in here. So hopefully that answers all your questions. Let me flip over to the camera real quick, and I'll show you in my garage how easy it is to get these things to creep into the beams. And something that you could probably do in your garage too to make life a little bit easier before you go out to the racetrack and you look like an idiot and the car leaps through the lights or it doesn't move. So hang tight. All right, so in the garage, you'll see I've got a smooth concrete floor, right? And you see that it looks like little burnouts, right? Here's some more up here. What I do is I force my girlfriend to sit here with a camera. And as you can see, I got a little tape marker here, right? So what I do is I either do it with the front tire or rear tire, but typically the front tire, right? And I'll measure this out 12 inches because that's the distance from top bulb to bottom bulb, right? And we're going to watch how far the tire moves and how long it takes for the tire to move. And I get it to the point where it barely hazes the tire on a smooth concrete floor. If you get it to barely haze the tire on a smooth concrete floor, then this thing is going to move into the second bulb easier. You can see I've done this many times, right? So it's all over the place, right? So I've moved my tape line many times. So like here's another one up here, here's another one up here. So with doing it this way, you can get this car to creep into the second bulb super smooth, so it doesn't disrupt the chassis. It doesn't disrupt the driver, because that's a big problem, right? I deal with one guy. He's a putz, right? And he knows who I'm talking. He knows I'm talking about him. He's a total putz, and if he presses the button, he loses his mind if the thing is too violent. If anything happens, and then he'll grab the Transbrake like halfway down the track. I mean, he's a total idiot, right? He's a good friend though, so I'm allowed to call him an idiot. But by doing it this way and making it nice and smooth every single time, you get yourself into a better rhythm, so you don't look like a moron trying to get a car to go down the racetrack. So hopefully this answered every single one of your possible questions about bumping and staging and whatnot through Holley Efi. So have a good one. And like I said, I got a lot of big tire cars around here. This is the next one. This car here, I'm gonna be doing quite a bit of videos on. This one's gonna be all about what not to do when you wire a car. There's a lot of stuff with this one that we're gonna fix and get right for the customer and make him happy. He's had a lot of problems with this and hasn't even made it to the dyno, really. So beautiful car, has some issues, but just tune in and subscribe, and I'm going to be doing a lot more thorough, in-depth videos on how to do stuff the right way and how to fix a mess. Like that's wrong. You know what I mean? Like we're going to go over how to shorten them up. I mean, that's pathetic. Same with that. You know what I mean? Don't build an injector harness and then coil up 24 inches up underneath the intake and call it artwork. We're going to go over all that kind of stuff, and we're going to fix him up so he stops burning up coils. But anyway, that's irrelevant to bumping. So hit subscribe, and you know, comment if you got any questions. You better not have any questions. You just shouldn't have any. But if you do, let me know. All right, see ya.